Hydrostatics, example 6, breathing underwater with a snorkel, during which your respiratory system is acting like a pump. So here is a snorkel tube filled with atmospheric air at 1 atm. Down here, your mouth makes a tight seal around the tube, and the piston represents your chest cavity. So when you breathe in, you'll be using your muscles to expand that mouth and lung cavity, opening up some space here. Your chest will be pressing against the water that surrounds your body, pushing back on that water to open up some space here, allowing the atmosphere to push air into that space, into your mouth and into your lungs, where it can exchange CO2 and O2 with your circulatory system, and you'll be breathing that out in a moment. But let's look at the work that your chest has to do in order to open up that space when your chest is underwater. Now, when drinking through a straw, your lungs are acting like a pump to raise water up to a higher elevation. Here, breathing through a snorkel, you're again acting as a pump, but what you're doing is pumping water out of this space here, pumping water out of that space to vacate that space. So the water that you have displaced by allowing your chest cavity to expand, pushing water out of some volume around your chest, the water you've displaced has to go somewhere. So ultimately, that water is going to be pushing on its neighboring water, which will push on its neighbor. And somewhere down the road, there'll be some water that has to raise up in elevation somewhat, gaining gravitational potential energy as a result of the work that you're doing here by applying a force with your chest muscles over a distance to expand your lung cavity. There will be 3 relevant forces acting on your chest piston here during that expansion. There is, first and foremost, the pressure from the water surrounding your body. If we are 3.5 meters deep in the water, as in this example, then that water pressure will be about 1.35 atmospheres. That's F 1.35, pushing inward on your chest, crushing your chest. Then from the air that is inside your mouth and lungs at 1 atmosphere, that is helping expand your cavity. So that'll be F1 right here, 1 atmosphere of pressure pushing outward on your chest, helping it to expand. And then the difference between those two will have to be made up by the force applied by your chest muscles. So the difference between those two outside water pressures and inside air pressures, 0.3 atm in this example, times the cross-sectional area of your respiratory tract here, or perhaps the cross-sectional area of your snorkel tube. That's the pressure that your body is going to have to provide. And that'll be equivalent then to this expression, the density of water times little g times the depth, times your depth as you're breathing, times the cross-sectional area of your tube system here. Well, your chest can't expand forever, so at a certain point, you're going to have to expel that air from your lungs and breathe again. So as you breathe out, either forcing air back up through the tube or breathing out through your nose, here are some bubbles then coming back to the surface. Your chest collapses again and gets ready for a second breath, pushing back on the water, allowing the atmosphere to push air into that lung cavity. Now, in any case, it's not likely that any person can breathe through a 3.5 meter long tube. More realistically, a 1 meter long snorkel is probably the most at which probably the longest snorkel through which an untrained person could breathe effectively. So that means you should probably abandon your plans to strap on some weighted boots and live out your crab person dreams at the bottom of that pond near your house, because you just won't be able to breathe through those 4 taped together pool noodles.